Hello everyone, welcome back to DevOps Impact Journey. So in today's video, we'll be discussing a recent news about Amazon Prime Video's move back to the monolithic architecture. There's been a lot of hype and speculation about this decision, but does it mean that Amazon Prime Video has found a major flaw in serverless architecture? Well, I'm here to answer all of that, so let's find out. Amazon Prime Video offers video streaming services to their customers, and they use a video quality analysis tool to monitor every stream and notify their operations teams if there are any video streaming defects. However, they faced a scaling bottleneck and high cost when trying to scale their video quality analysis tool. So what does that mean? Let's dive a little deeper into their architecture. Initially, Amazon Prime Video used a distributed architecture with serverless components like AWS Step Functions and AWS Lambda. So AWS Step Function was orchestrating a bunch of AWS Lambda functions that shared data between them using a transition bucket, transition S3 bucket. So every function was making S3 bucket calls. In another scenario, the step function had a scaling limit built into each AWS account, so they were hitting account limits when they were trying to scale their step function. So these two major components made their architecture really hard to scale and very expensive at the same time. So in order to mitigate that, they re-architected the whole thing and moved their workload to AWS ECS tasks. So what that means is they were able to rebundle those different separated Lambda functions into one piece of monolithic application that now no longer needed to make S3 calls, for example. They could use the in-memory storage to be able to share those image buffers between those subcomponents. So that helped them reduce a lot of their S3 calls. In other words, they were also able to scale those ECS tasks because ECS is very scalable. So they were able to scale those as needed and able to serve a lot more video quality analysis buffers than they were able to before. Now, in terms of whether they've identified a serious flaw in serverless architecture, the answer is no, because their architecture worked when they were initially bootstrapping this solution, and they were able to quickly spin up some Lambda functions and able to test these tools. As their users grew, they realized that it was hitting scaling limits, and they re-architected it again into the slightly more monolithic structure. And I think this is a really nice way to transition your architecture when you're bootstrapping it, a really quick solution, into scaling it for the future. There are a lot of comments online about how embarrassing this is for Amazon's team to have made an error like this. But I think that's how we grow our solutions, and that's how we learn, and that's how we share. And we should be grateful that Amazon Prime team is sharing this so that we can learn from their mistakes. And I think that's a really good thing rather than a bad thing. This is just a specific case for Amazon Prime Video's monolithic requirements, and it doesn't indicate that the serverless architecture is flawed in any way, and we should start re-architecting our applications or our architecture into a monolithic structure. This was just what made sense for the Amazon Prime Video's particular solution for monitoring these video qualities, and it should be taken on a case-by-case basis. So in conclusion, this hype and speculation about Amazon Prime Video's move back to monolithic architecture, in my opinion, is very overblown. It doesn't indicate that there's a major flaw in serverless architecture, but indicates a very important point about selecting the right architecture for your specific use cases. So that's it for today. Thanks for tuning into DevOps Impact Journey, and I'll see you in the next video.